Thank you. Okay, I have to apologize. I haven't expected this to be such a low resolution, so some things will be a bit constrained. So let's see. My name is Nikolai Kondrashov. I work at Red Hat at the Common Login team at the moment. I focus on this project, user session recording project. I also maintain free radios packages, and in my free time I found it, and I maintain the Digiment project, which is working on improving Linux support for generic graphics tablets, those that are not made by Wacom. And I also, well, play with embedded engineering and electronics as a hobby. So why this project? So many enterprise customers and not so enterprise customers were asking us if we can supply session recording solution with our identity management solution. Because, for example, government organizations and some financial institutions need to record user sessions on sensitive systems, and some organizations are required by law to do so. They also need to track what the contracted administrators or just simply contractors who come in and do something on their systems do on those systems. And sometimes they just need to keep audit and keep track of what's going on and being able to review later what was going on and do forensics. So ideally, they usually want everything recorded, everything that users did to the best detail that they can get, whatever they saw on the screen or did on the system. They want to store that somewhere safe and in a central location where they can search the sessions, they can search inside sessions and find out who did what and how it broke and how did they break in, and possibly what they stole. So there's plenty of commercial offerings, and there's a great range, like starting from the systems that you can basically buy a box, put it on your network, plug in 2 network cables, add the encryption keys, and have your SSH sessions decrypted and stored, and have your database sessions decrypted and stored, and or you have some software installed on your own system that does the same thing, does the jump server or does the proxy server, or install software on the target system where you want the things recorded. Then there is a variety of what they record, like again, you can record the traffic, you can record the keystrokes, you can record the display, you can record the terminal, you can record Windows graphical sessions, you can record X desktop. Sometimes you can record applications that were started, URLs that were opened in the browser, etc. Often those systems are integrated with identity management and access control, so you can, for example, see particular user, see the sessions that the user has open, and look at the session that's going on right now and terminate it if necessary. And they have often, the central storage and analyzing software and the searching interface. And of course, the playback. So those are commercial offerings, and of course, they cost money, and sometimes a lot of money, and sometimes they have very, inconvenient licensing terms, like, for example, per server or even per user. And since they are commercial, they are normally, and I think in most cases, they're closed source, and you can't look inside, you can't fix it yourself, you can't figure out how it works, and you can't improve it yourself. So obviously, free would always be better, but also open source, so that it's easier to manage and you get all the benefits. And of course, many of the large organizations still want support, which Red Hat can provide. So what exists already is there is some things that are pretty close to this, but yet pretty far regarding the integration and the convenience of use. So the ancient thing called script, which is everyone knows about it, possibly. But it is not intended as a security solution. It's like record yourself solution. And if you want to make anything secure about it, you need to do lots and lots of work. And I saw one installation where there was set up a jump server, script was secured, you couldn't do anything, but there was like lots and lots of work on top of it, and it was still, barely meeting the specifications, which is good enough. Then there's the sudo IO login, where you can enable login the terminal IO on your sudo session. Then that session is being stored in the under var somewhere, and later you can search it even, and you can play it back, but it's not centralized, and if you want to centralize it, you have to do something with rsync or some such things. The closest thing that there is open source is the TTY audit subsystem in the kernel, where it plugs into the TTY layer and it logs user input to the audit log, but it doesn't log output. So when we were starting this project, I was investigating if we could perhaps expand it to log output as well, but in the end we decided against it because it would slow us down at the start of the project, where we just need to start, because working with the kernel is sometimes involved in a lot of discussions. And then later we found out from the audit guys that well, they consider that it would probably not be very performant because the audit interface from the kernel is not very efficient. So again, so people need to record what the user sees on the screen, what they enter into the terminal, what they execute and what they access. The organizations need to get it off the machine where this is happening as soon as possible, so it's safe. They need to store it centrally. They need to search, analyze, and correlate with other events on the system and possibly on other systems, and they need to play it back in real time as the session is happening, and later obviously as well. They need to also be able to control it centrally, so that they can control many systems and say, like, record this and this and that system, and record these groups of users, and record this particular user, etc. So it lends itself, this task, very well to the log system, because we have already lots of data there, and we have the audit log, which specifies what the user accessed, and you can configure audit to record what the user accessed and what the processes the user executed. We have logs from other systems, and the login servers know how to deliver your data, and they know how to spool and everything. And there is already plenty of solutions that allow you to search, analyze, and visualize your logs. So apart from there being everything there in the logs, it's also good that we don't need a separate infrastructure when we set up this system. If you want to add session recording, you wouldn't need to set up a new system, and you watch out new ports and deal with your firewalls and everything. And all those things that are already done for your login system. So you don't need to set it up. Well, you need, but not so much as a separate system, and you don't need to maintain it as much. And being in there together with the logs that you usually want to look at makes it easier to correlate. And it's not just like, you know, a system where you go to one place and there's a system where you look at the video and then you have to go to another place and look at the logs. It's all in the same place, and you can immediately see what was going on. So, so first we wanted to choose something that would help us analyze and view all this and store it. We wanted something popular and scalable to the enterprise levels, and well, so people would be happy to work with it and the development would be active. So naturally we chose Elasticsearch and KIBANA because those are quite popular in the log analysis solutions. And we have a sister project in the common login team called MyQ, which works on, let's say, uniting all the logs that Red Hat's product produce and putting them into one storage where you will be able to nicely analyze it. And the work involves, for example, ensuring that your host name is always in the host name field where you can find it for all kinds of logs. Your timestamp is always in the same format and in the same reference. Your other fields are also in the same place, so that you can, you know, so that it lends itself better to correlating, and you can quickly figure out how to get together those two logs and see the correlation. They also work on providing dashboards that are ready when you install this solution, and they are already doing that in OpenShift and going to doing that in OpenStack and in other places. And actually there was a presentation about this last year here. I don't know if they showed up here this year. So the remaining tasks are to control centrally where, what, and how we record. Also log what user enters and sees, because yeah, it's nice that we want to do that, but there is nothing that does that. And we want to kind of organize audit logs better because they're a mess. It's a mess. And we need to deliver that to Elasticsearch somehow. And we need to play back from Elasticsearch. So for center control, naturally, we think of using the our identity management solution, FREEIPA, and SSSD, and the peripheral tools as well. And if you don't know, FREEIPA allows basically to do what Active Directory does on Windows, to manage domains, hosts, groups, and users. And the SSSD part allows you, for example, take your laptop away from your network and still being able to log into your domain with your domain credentials and work offline for a configured time that administrator set. So for the SSSD part, we already have basic configuration for session recording where you can say which users and groups to record. But for FREEIPA, we have just the design for now. So for login input and output, we made a separate tool because we didn't find anything that would do the same thing. We call it TLOG for terminal login. And it goes between the terminal and the shell that the user runs. Captures the I/O and converts it to JSON because JSON is the language that Elasticsearch speaks. It logs it to whatever you tell it to, like syslog or file or journal. And there is also part of it that can play back those recordings on the terminal. So to make sense of audit logs, we made this tool called AUSHAPE, and the name is after all the tools that Audit Suite provides. They all start with AU for audit. And basically it uses the libau parse library that is stock audit and parses the audit logs and then tries to beat it a bit into shape so that it's more structured. And it can convert the log like single shot if you want your file converted, or it can sit under AUDIT and then convert it on the fly and send it somewhere else. So yeah, we also have the recent feature of audit implemented, support for it implemented in AUSHAPE, where audit can kind of normalize the event and try to make sense of it and extract the typical, the security parameters of the event, such as who did the thing, who did the thing, and on what it was done, like categorizing into subject, object, action, result, and everything. So that makes it easier to visualize this and correlate. So to deliver to Elasticsearch at this moment, Red Hat ships rsyslog, and you can install, of course, FluentD or Logstash and deliver with them, or you can, if you use OpenShift, for example, you can use VIQ to set up to deliver it to Elasticsearch. So for playing everything back, we are working on the web UI to play back data from Elasticsearch and to see the terminal that the user saw, and being able to search for input and output and for comments and files. And we plan to make it reusable and embeddable so that you can embed it into this product or that product, providing the data source. Right now we are working on doing that in COCKPIT, which is a server management web UI. Many probably have heard about it. And which I'm going to show you shortly. So the basic shape of things is we take the terminal I/O with TLOG, and we take audit events with AUSHAPE. We push it as JSON into logs, then deliver it with any combination of log servers to Elasticsearch. Then we are able to view this data with KIBANA in general, for example, or Grafana. And then we have web UI, we are building the web UI, which will be able to play it back. So, demo. Oh, now for something interesting. Actually, how many of you had their sessions recorded ever? Oh, cool. How many of you has set up such recording? Okay, that's great. How many of you wish they set up such recording? Okay. Oh, there is one person. Okay. Okay, good. So in this demo, I'm going to show a user logging in into the system, but they are recorded. We will start the playback at the same time, and we'll see the session being played back as it goes on. That playback is going to be, that recording and playback is going to be happening through Elasticsearch. So the session will go to Elasticsearch, and we'll play it back from Elasticsearch. After we did some work on the terminal, we'll take a look at the journal logs in the journal, and then in Elasticsearch. And then I'm going to show you the how it works in Cockpit at the moment. So I will need to sit down because this table is very low. I'm sorry. So let's go. So here I'm going to log in into a system, and here I'm going to play it back. First thing I'm going to do when I log in, I'm going to find out what the audit session ID is. So it's 31, and I'm starting the playback now. And the playback is happening on the right, and the actual session is on the left. So let's do something. This user doesn't have a sudo password, so I'll just run it. So we have sudo in the log. Let's do some interactive editing. Oh, finally it fits. Okay, have something more interactive. Okay, and that's enough for our short session. So as you could see, everything was played back here with a little delay because TLOG is caching data before it writes down a little bit, which you can configure, because it wouldn't be good for your log if you logged every keystroke and everything. So it has to punch it up a little into messages. And then it takes a while for Elasticsearch to index those messages and to make them available for the playback. So our journal messages look like this. If I can find them. So one of those is here. It's not very readable here, but you can see that it basically start of a JSON object here, a bunch of meta fields, and then time and data, and then the capture of the output. This is a piece of Midnight Commander here. At the same time, we also recorded audit data here. This is also in JSON here. This is parsed audit data. It's quite a long one because I have everything enabled. And you can, this is probably the audit log message, which this one made from. So this is not very readable in this log because those events can be quite long. You can configure what size you want of those events, and TLOG would split the I/O into smaller chunks to fit that limit, and AUSHAPE will have to drop some fields if they don't fit. So you will have to set up your system so that doesn't happen. Okay, so in KIBANA, this might look like this. So let's filter out audit session. Which was it? Was it 31? Yeah. Okay, cool. So these would be audit messages converted with AUSHAPE, and this is just one of them. This has the source text of the audit message, the parsed data, all the fields that were there in the audit message, plus so-called interpreted field where, for example, the UID is converted to username before being transferred to another system. And then there is the normalized data where you can see the action, negotiated crypto key through SSSD, and the object was user session, and the subject was user 3, and the user 3 went to root or something like that. So we can, for example, take a look at the processes that the user executed. Let's say and let's see a specific, let's see, who am I? No, that was under sudo, so it did not happen. Let's see, Vim. Yeah, there is this Vim comment here, an event. So this was Vim with one argument. It's a bunch of data about the executable, the user who did it, the syscall that happened, and the original message, and then again normalized data, which is most suitable for analyzing. And for example, we can see what was happening on the screen through about the same. So these are all messages concerning the terminal input and output, and we can, for example, search for the sudo output there. There we go. There is a piece of sudo output, and it says here 3 incorrect password attempts. This is a piece of output that was captured. Now let's take a look at what we have in Cockpit. So this is a rather small screen for Cockpit, so I don't know how it's going to cope, but we'll see. Okay, so here's our work in progress page. This is a list of sessions that were already recorded, and we are going to start a new one. And it should appear on the right shortly. Yeah, there it is. So here's our terminal. We can go in as the session is happening, and we can't fit this at all. So let me see why it doesn't scroll. Some magic, probably. Come on. Ah, I know why it doesn't scroll, because the window is too big. Right. Just a moment. So here's our recording. You can take a look at it, and I can say fast forward to the end, so it syncs up with this. We can do some stuff like this. So it will cope with the resizes and things like that. So right now we're working on the panning and zooming of that. If the window is too big, for example, like if we just make it very, very big and becomes unreadable. That is rather useless in this way. So they have a pull request for that. You can do some stuff like you can rewind again, you can play back, you can make it faster. this happening rather fast. So, or you can, for example, step through your recording on pause or while playing, and don't have to use the mouse on that, and see what was happening in slow motion. You see the resizes and repaints are separate here. You can also, for example, if you're, oh, that was too fast. Come on. It's trying to do things too fast. Okay, so when you're playing back, for example, the user has left their session for a long while, like for several hours. You don't want to wait those several hours, and you don't want to speed up the recording and then still wait like half an hour. So you can just click this skip the pause and jump right to the next action on the terminal. So that was the short demo. So if you want to record a user session, there is a special tool called TLOG rec session, which you can put as the user shell in your user database. Then when the user authenticates, let's say, on the console with login, so they authenticate via PAM, then they ask NSS login asks the NSS what's the shell, and the NSS says it's TLOG rec session. Then login starts TLOG rec session, and it gets the actual shell to start from its configuration on environment variables, starts the actual shell under the PTY, and then starts logging whatever is passing between those to whatever place you configured. So with SSSD, we used the ability of TLOG to get the configuration from the environment, and also the fact that SSSD has its own NSS and PAM libraries. So when the user logs in, SSSD puts the actual shell to start into the PAM environment and substitutes the shell to start in NSS library, so that NSS thinks that it's TLOG rec session. And when login starts TLOG rec session gets the actual shell to start from the environment and starts it. In the same way, the next step would be passing additional configuration to TLOG rec session, which is going to be for FREEIPA. So with FREEIPA, the plan is to associate recording configuration to HBAC rules, which would allow you to match users and host names to specific configuration. And this is done similarly. This would be done similarly to SE Linux maps in FREEIPA. And SSSD would have to then download a set of HBAC rules which apply to specific host it runs on, and match each user as it logs in, and check if the user has been recorded and apply the configuration and everything. So as I said before, TLOG can record to journal, through SD journal interface, through syslog interface, which is supported by journal, rsyslog, and other login systems, and also file if you want to test it. You can control what you want to record, the input or output, and the input login is disabled by default. You can disable window resizes if you really want to save a little bit of size. You can limit the rate at which the log messages are logged. So for example, if the user just cats a long file, your log is not flooded, or if they just like cat def0 or something on the terminal, it's not overwhelmed, and you can set up either throttling or just dropping the packets. You can configure if you want the data accumulated longer or rather logged as soon as possible. If you want to save, like have it more interactive, or if you want to have saved a little bit on logs. And yeah, you can play back from Elasticsearch, and you can play back from journal or file. From journal, I mean the journal log, that is systemd journal. So yeah, also in the console, when you play back, you can control the speed and pause, resume, and fast forward as you saw in Cockpit, and you can step through the recording the same way. We don't have rewinding yet anywhere, about which I'm going to talk a bit later. So we designed the schema that TLOG uses for logging this way so that you can search it and you can stream it. So that means that both the streams are chopped down to the messages, as I said before, and we store input and output separately so that they are not intermixed, so that you can actually search for strings there. We store the timing information about what happened where also in a separate field so that you can still search the data. If there is, since the JSON only supports UTF-8, we have to filter out invalid UTF-8, which can be just a binary on the terminal, and we need to still store that separately so that it's not lost. If somebody dumps a binary on the terminal or like open office document on the terminal and then make it off with it, we can still recover that and see what was being taken. Yeah, and window resizes are preserved as well along with the timing. So AUSHAPE pipeline starts from the kernel, where kernel feeds the data to AUDIT through netlink. Then AUDIT pushes that binary data to AUDIT, which is a plugin manager for audit. And one of those plugins can be AUSHAPE, which then converts it on the fly and pushes it off to the login server, which can then deliver it to Elasticsearch. So for AUSHAPE, we tried to make the schemas look as close as possible to the audit logs so that people familiar with audit logs can still make sense of what AUSHAPE produces. And in particular, we try to keep the record names and the field names the same. We did one major change in that we merged separate records in the logs that belong to one event into one object, because some events that audit system produces can be made out of several log messages, and we don't want that stored as separate documents in Elasticsearch, because that would be a hassle to correlate. So we put it in this, like put them together into a single document, which turns out to be very convenient. So here's a very, very truncated execv event, both in XML and JSON. And we saw that in KIBANA, displayed rather differently, because that's the way KIBANA works. But here is the basic structure. So you can see separate records, which correspond more or less to separate records in the audit log, and then separate fields, which should be named the same as fields in audit log as well. So then there's this normalized data, which I was talking about, which is really useful for visualizing. And the cockpit UI, which you saw, works by having TLOG log to journal, where we add a copy of a few of the fields to journal fields, so that we can find particular recordings in the journal, and we can aggregate by recording ID, so that we can display that list of recordings. And then when you open the playback, Cockpit runs basically journal CTL on the host side, which with a few matches, like for recording ID, for the UID of the recording process, and pushes that JSON to browser, and we load that and play it back. So there are a few fun problems to solve still. Well, there are more than a few problems to solve, but fun are those. So we need to convert character sets, because not everyone uses UTF-8, particularly in Japan. That is a bit of a problem, because we need to detect when it's invalid, and we need to preserve the binary. Still, if in case we need to keep it, so we'll likely just keep the original and also add the converted text and make that optional. And rather more fun problem is that terminals are very complicated things, and terminal emulators in particular, and there's huge documents describing all the escape sequences that they work with, and some terminals are different, but we have only one terminal, for example, in Web UI to play it back with. It cannot support all the control sequences and all the different terminals. So also, when we play back on the terminal, we simply dump that data to the actual terminal, and that terminal can be different, so that might not play back correctly. So our idea to this is we take a terminal emulator library, which provides a library like terminal emulator in your program, which you can feed just the actual data that would come onto the terminal usually, and out comes high-level primitives like move the cursor there, draw this thing there. So this way we would have always the same terminal type presented to the programs that we record, and this way we will limit the language that these programs speak, and it will be easier then to implement the terminal playback in the Web UI, and it will unify different terminal types. So for AUSHAPE, the first challenge is that audit log is a mess, and it's a mess because part of it is generated in the kernel, part of it is generated in the user space, and all those people who generate those events, they don't really always speak to each other about it. So there is no person there that knows all the ways that data can appear in that log, including the audit developers. And it would be nice to make it more useful, more specified, so that you could rely on and you can look up how this particular event could look and expect where the data would be, but it is difficult. So we try to keep the schema simple, and the next step would be working with the audit guys and improving their dictionaries, that they have dictionaries about which record can appear and which fields they can contain, and making them more specific, and then maybe writing some tests that verify that. And again, we need to convert the character encodings, because file systems can contain files which are named in different encodings, and for particular installations it can be something else, not UTF-8. And the same thing, we also need to preserve that in case encoding conversion loses some data, which can happen. So we'll probably provide an option to keep the original and the converted. So for Web UI, right now we have discussed a new design with the COCKPIT team, and we are going to try to integrate it with the logs page that they have, and make it possible to see the recording and the logs at the same time. So when you play back, the logs would scroll by, and you can filter out, for example, the logs that belong only to this session. And you should be able to search the logs and click on the log entry and rewind to that position in the playback. There are a few problems, especially with the rewinding thing, where you would want to position the playback exactly, like randomly on this point, on that point, on that point. That is necessary for correlating with the logs. And since the terminals kind of keep a lot of state, you in principle need to know everything that happened before this point. You need to accumulate all the state right from the start. You cannot just start playing from the middle, because, for example, something at the start of the session set the background color to blue, and then thought, okay, I'd like black on blue. And you don't do that, you just keep the black background and start playing from the middle. You won't see anything, because the text is expected to be on blue background, and you see black on black. So to do that, we would like to do something similar to keyframes, basically snapshotting terminal state at regular intervals in the recording, and then using that, restoring that state from the closest state from the position that you want playback from, and then playing back a little bit, and quickly resuming from the position you specify this way. At this moment, probably the first thing that we'll do would be just, playing every time from the start when you reposition, which is, for example, a thing that SCHEMA does. If you know what SCHEMA is, it's a website for publishing your terminal recordings that you want to share with somebody. So searching for input or output, or for example for commands executed or files accessed, would be difficult with journal because journal doesn't support searching for partial text. In the journal, they only support searching for whole fields, and it's because they index the data this way. So we'll need to think of something, and we also need to extract the I/O into separate fields, probably, if you want to search them. So if you would like to try, I just released the new version of TLOG. It has just 3 dependencies which are easy to get. Take a look at README. It explains everything, including how to set up forward and log into Elasticsearch, including RCS-log configuration. And for the start, you can just log record to a file and take a look at how it looks inside and play back immediately from file. Or you can experiment with logging to journal. That is quite easy to do. With AUSHAPE, you can just, well, I haven't released in a while, so better pick the latest source. There's just one dependency, the audit libraries, and you can just take it, feed it your own audit log and see how it looks. It won't send it anywhere, I promise. And you can, and there are instructions for setting up forwarding to Elasticsearch as well. So for Cockpit UI, it is a bit more challenging. You will need to read the HackingMD document, which Upstream provides, and check out our branch, because this is still not upstream. After you set up Cockpit, that's the most difficult part. You can easily install TLOG from an RPM and just create a user, set the user share to user bin TLOG rec session, and log in as that user, and that session is going to be recorded to journal by default, and Cockpit will see that, and you will be able to see it on the session recording page. That's it. Any questions? Yes?
Do you have trouble searching what was run under sudo?
That's an interesting question. So, yeah, the question was, do we have a trouble searching for whatever was run as under sudo? So sudo logs its own audit messages, and you can search for that. But if you have interactive session with sudo, and you have not set up login whatever the root executes, well, you're not on your own, but in general, if you want to record exactly what was executed under the root session as sudo or as another user you sudo to, you will need to set up explicit rules for that in audit. But that will be recorded, as well as the terminal I/O will be recorded for that sudo session. Yes?
Is there any platform dependency? Can I run it on any distro? There is a suite of tools, so at least part of it.
I think you can run everything on at least Debian and Fedora and RHEL, and the TLOG can work as even on RHEL 5 without journal support, of course. And AUSHAPE, at the moment, might have a problem building with older audit, but we can fix that. There are no pre-made containers for this, but you can certainly make one, I think. There might be a problem running TLOG as recording user sessions in a container, because there wouldn't be, you will need to set up user sessions. I don't know how that would work, but you can just run the recording. There were a few guys talking to us about recording user sessions that are going to containers in Kubernetes and OpenShift. So my answer to that would be probably using TLOG library to embed it into Kubernetes, or well, into Kubernetes, yes. But nobody has approached us with this yet. So we would be glad to work on that. Yes? Yeah, go ahead.
Is the communication between the logging utility and the data storage encrypted? Or because it's basically spying from the user?
Yeah.
Is it encrypted?
It's up to you. The question was, is the data going through the log, like this user session is encrypted? Well, you don't really need to encrypt it in your local machine, but all the major login services support encryption, both, I think, on disk and in transit. So they all have transport that is recording, and you can use HTTPS with Elasticsearch for the final leg of the journey.
So mine is not that question, it's just helping to answer the question about running things in your instance. Keep in mind that SSSD must be at least the 116 release. All the work is ready, was ready for the 116 release. I guess, if I remember correctly, right?
Yeah.
So if you are running like lower version, like older version, SSSD is not going to work.
Yeah, but you don't really need SSSD if you want to try the recording. I mean, it helps, but you can get by with just changing user shells. And there is support for specifying user shell by making symlinks to TLOG accession, where you have a name of the shell in the symlink, like similar to BusyBox, if you know what it is. Sure.
Has that been ever tried on a non-Linux environment like Enterprise Solaris or other ancient stuff?
So the question, was this tried ever on something that is not Linux, in particular Solaris, for example? No. I would be glad to see how it works and do the fixes. There would be, well, journal wouldn't work. There might be some Linux idiosyncrasies with how the terminal, how the PTY is set up, but I think that could be quickly amended if there is a problem. So if you want to try it, please try and submit bug reports. We would gladly fix it. Yes?
Do you support something like masking of some data? Like I don't want to record in my password file?
No, there can be. You can write a code for that. It's like the architecture would allow for something like that. Otherwise, don't record user input because the passwords are there. That's it. Yeah. And if the user dumps it on the screen, the passwd file, well, the passwords are not there, and they cannot dump shadow, so at least that is that will protect you. Anyone else? Yes?
Do you have some particular solution to basically several hours worth of session when the user makes, for example, tail -f on some log file and dumps a huge amount of data to you?
So there is rate limiting. First of all, you can just say, well, let in only a trickle if you'd like. Then if it's very long, then no, but I guess you can think of something on the storage side, provide some triggers in Elasticsearch that would warn you that this is happening, for example. We have not thought about it, honestly, yet, but it's a good question, thank you. Anyone else? Okay, thank you very much. Just a moment. Okay. I should not forget what this is.